Hi everyone, welcome to CodeTav Management. So over the last few videos, we explored form login, which destroys your server's memory with stateful sessions. And also in the last lecture, I have discussed about the basic authentication, which destroys your database performance by querying on every request. So how do modern companies like Google, Netflix, and massive microservice architectures actually handle the authentication at scale? So the answer is JWT, JSON Web Tokens. So today we are doing a complete deep dive into JWTs. So we are going to break down its exact three-part structure. Mathematically, we will prove how the cryptographic signature prevents the hacking, and also we will expose the four dangerous vulnerabilities that hackers use to break JWTs if you configure them wrong. So let's build the scalable applications and APIs. So first of all, what is a JWT? So to understand why JWT is a superpower, you have to remember the old way, like the session-based auth. So in the old days, when a user logged in, the server actually created a session in a database and saved it in a memory and gave the browser a JSessionID cookie. So if you had 10 microservices, then every single service had to pause and query that central database to ask, is this user logged in? So that is a massive bottleneck. So JWT fixes this by being 100% stateless. So when a user logs in, the auth server generates a JWT, and this token contains all the user's information right inside it. Okay, so the client stores it and sends it in the authorization bearer header. So now when a microservice receives the token, so it doesn't need to ask a database anything. So it just mathematically verifies the token and lets the user in. So it improves the scalability. Okay. So this is the self content. The token contains all the necessary information about the user and avoiding the need to query a database more than once. And secure, it is digitally signed using secret HMAC algorithm or a public or private key pair RSA. So where is JWT used? So for authentication, so once a user logs in, each subsequent request includes the JWT. And authorization, the JWT payload contains roles or permissions, allowing the server to grant or deny access to routes. And single sign-on. So because of its small overhead and ability to be easily used across different domains. Now, JWT versus session-based authentication. So JWT fixes this by being 100% stateless. So when user logs in, the auth server generates a JWT and this token contains all the user's information. So like that's why as a session-based JSON ID that is also stateful, then JWT token-based that is stateless, stored on client. Now database lookup, session-based JSON ID means basic authentication. It's required on every request. For JWT, there is no DB lookup required. Scalability. Scalability for session-based is poor, requires shared DB or Redis, and for JWT it is excellent, self-validating. Transmission. So session-based, the transmission is cookie, and like through cookie the thing is happening. Like through cookie, in the JSON ID, JSession ID will be transferred or transmit, and in JWT in HTTP header you will have authorization BRR token. Now, the anatomy of a JWT. So there are mainly three parts of JWT. Part one is header, part two is payload or claims, and part three is signature. So if you look at a raw JWT, it looks like a massive string of random garbage, but it's actually three distinct parts. This header, payload, and signature. So the first part is header. So Header tells us the type of token and the algorithm used to sign it, like HMAC or RSA. Okay, so type and algorithm. So here you can see HS256. That is the algorithm being used, and type is JWT. Next part is payload. So this is actual data. We have standard registered claims like subject, issuer, role, expiry time. Okay, so you can also add custom claims like role you can add. So you can see like subject is user 12345, role is admin, and expiry time also mentioned. Okay, so critical security warning: the header and payload are only base 64 encoded, those are not encrypted. So anyone can decode and read this data. Never put passwords, SSNs, or proprietary secrets in standard JWT payload. Next is signature. So like uh this is like if anyone can decode it, so what stops a hacker from changing role user to role admin? So there the signature come into picture. So the server takes the base 64 header, the base 64 payload, and a secret key that only the server knows. So it masses them together using a hashing algorithm, which is you can see here HS256 algorithm is being used here. Okay. So like if a hacker alters even one single letter in the payload, the math changes. So when the server recalculates the signature, it won't match the hacker's signature. So the server instantly rejects the token. And this guarantees token integrity. So again, from here I'm just reading, the signature is created by taking the encoded header, encoded payload, and a secret key, and the algorithm specified in the header. Like HMAC SHA256 base 64 URL encoded header plus dot plus like concatenated with base 64 URL encoded payload and secret. So this signature proves the token integrity. If a malicious user decodes the payload, changes their role to admin, and re-encodes it, the signature will no longer match the payload. So the server will reject it. Example of API request, like client store the JWT usually in memory or secure storage and send it via the authorization header. Like in bash, like this is the call of your API, like this is the one get request HTTP API example.com secure data, and header there we are passing the authorization BRR token, this one. So the major architectural challenges and solutions: the first one is the invalidation, like the token invalidation or the logout problem. So because the server has no memory, you cannot easily log a user out. So a JWT is valid until it expires. So to fix this, you must use very short-lived tokens and maintain a blacklist in Redis for revoked tokens. So like solution is this only, like see, because the service is stateless, it cannot simply delete a session to log a user out. A JWT remains mathematically valid until its expiry time. So solution is keep the JWT expiry time very short, like 15 minutes. Use a long-lived refresh tokens to get the new JWTs. If a user logs out or is banned and their specific token ID to a temporary blacklist in Redis until it expires. Okay. Next is payload visibility. Anyone can read the payload. Solution is if you absolutely must send the sensitive data in the token, you must implement JSON Web Encryption, which encrypts the payload contents. So whatever payload you will pass, you need to pass the encrypted one. Next is the algorithm none attack. Hackers may attempt to modify the JWT header to algorithm none, which removes the signature requirement. So if the backend library is poorly written, it might accept it. The solution is ensure your backend JWT validation library strictly enforces specific allowed algorithm, like only RS-256. If hacker will change that, it will not accept. Now JWT exploit. So in asymmetric cryptography, like RSA, attackers might embed their own public key inside the token header. Solution is never trust keys provided within the token. The backend must always fetch its validation keys from a trusted internal source or an authorized, well-known JWK.JSON endpoint. Okay, so never trust a public key sent inside the token. Always fetch your keys from a trusted, hard-coded, well-known JWKs.JSON endpoint. So top interview questions and answer I will discuss, like is JWT encrypted? A standard JWT is only base 64 encoded, not encrypted. So it relies on a digital signature for integrity, not encryption for confidentiality. Why JWT considered stateless? Because the server doesn't need to store any session data. All the information required to authenticate and authorize the user is content within the token itself. What happens when a JWT expires? The cryptographic validation fails and the server rejects the request with a 401 unauthorized. So the client must re-authenticate or use a refresh token. Why is JWT heavily preferred in microservices? Microservices are distributed. If using sessions, every microservice would have to constantly query a central session database to verify users. So with JWT, every microservice can independently verify the token using a shared public key, and that eliminates the uh, query of the database. It improves the performance as well. Okay, so JWT is the absolute foundation of modern API security. If this deep dive helped in you to understand it, then just hit the like buttons and subscribe to CodeTav Management and get ready for our upcoming uh, uh, lecture. So there also mainly I will discuss about more deep dive on JWTs, and then we will move into the OAuth 2. Okay, so till then stay tuned. Bye everyone.